All right, this is Dr. Shocker, and I'll be joining you all in class next week to talk about civil engineering. But in the meantime, because I messed up my schedule, I'm going to give you a extra talk today that I had to record because I've got meetings. So I'm combining two things that I think are kind of cool that I've done before, but kind of tailored them to our class here. And we're going to talk about concrete, and then we're going to talk about using concrete for zombie resistant structures, and then you'll have a little assignment. All right, so forgive the kind of top of the screen here, and I'm not going to show you my video of me because you'll see me in class next week, but also so you can see the slides clearly. And by using this interface, I can mark on here too if we need to. All right, so let's just start out. You may or may not know I'm a civil engineer and I work in the structures area, but my specialty is concrete. So concrete buildings, concrete bridges, you name it. And so let's talk a little bit about concrete, which I'm sure concrete is cool, sounds a little bit weird, but I actually think it's really cool. And it's the most used material on the planet after water. So there's a lot of it. So we call this how to tell the difference between cement and concrete. Super important. That's something I'm going to ask you next week. Make sure everybody has got that. And other glimpses into this amazing world of concrete. So these weird initials after my name have to do with my credentials as an engineer. So I have a PE, which is a professional engineering license, which means I can stamp drawings and approve drawings. And I'm a lead AP, which means that I've taken the certification exam to work on sustainable structures. So there's training involved with that. And we can talk a little bit about that next week as well. All right, so what's cool about concrete? Well, concrete is very formable. So both this first slide that we looked at, this is a artwork basically, but the cool thing about concrete is you can bring it right to the field, and if you can make a shape to pour it into, you can make a sculpture or whatever into that shape. So it's completely formable. Architects love it because of, the flexibility you have to do all kinds of different shapes and different things with concrete. Whereas if I'm looking at, a steel beam or something like that, that has to be done at a place that can handle molten metal and pour it into forms, and then it has to be transported to the site. So this is the other reason that concrete's used so widely across the world is if you've got some of the basic materials, you can go ahead and pour concrete. All right. It's sleek, contemporary. So you might think of the old, some concrete doesn't look so sleek or contemporary. This is definitely something we're seeing more and more of in combination with a lot of daylighting through cool windows like this particular house. One of the things here is we'll talk about that concrete is really good for holding heat or cooling. So let's say I live in the desert, and during the evening time, as the concrete cools off, it stores that energy almost like a battery. And during the daytime, I'll have cool concrete walls and then it'll heat up over the course of the day and then take the heat out at night, and vice versa for using it in a climate like Minnesota. All right. So it can be very sleek and contemporary. Now, here's the important part that's kind of my public service announcement, and that's that concrete and cement are not the same thing. Um, Concrete is made up of a bunch of components here, okay? So it's got cement, which is the gray powder, and that is made from limestone, and I'll show you that process. But the rest of concrete is made up of things like rock, which we call coarse aggregate, sand, which we call fine aggregate, water, and then there's actually air bubbles in it purposefully. So we use a chemical admixture to put little air bubbles inside of the concrete, and that helps us resist freezing and thawing because as long as there's space for the water so let's say there's a little moisture in the pores, as long as if I have space so that that doesn't fill up, it won't freeze and crack the concrete. That's a whole nother discussion. But it's something you'll see in concretes around here in Minnesota is we'll have around 6% air. So cement. So when someone says a cement sidewalk, that drives me crazy because that means that I'm walking on powder, whereas concrete's the hardened version of that. And cement is made from limestone, and then it goes through a chemical process where it's calcined, and it comes out as cement. There's a lot of other pieces to that process, but it has to be heated to a very high temperature, 1800 to 2700 degrees Fahrenheit, right? So it'll be in a kiln and it's rotating and it comes out in what's called clinker or little chunks and they grind it into cement. But this is the material that when you put water, it reacts chemically and then it hardens. So when I take a bag of cement and I add water, then I will get kind of the basic chemical reaction that gives me concrete. Because it is a limestone, so in other words, CaO for cement, calcium oxide, that because of that, that is what gives us the off-gassing of CO2 in the process of making cement. And so this is the part where we trying to look at different ways to make cement and different materials to use so that we don't have this big contribution to greenhouse gases. I'll touch on that a little bit next week. So here's concrete. You've seen these blocks. These are masonry blocks or concrete masonry units, CMUs, cylinders of concrete and other specimens like this. These guys don't have the big rock in them. They kind of, if you look at them, they look like a concrete Rice Krispie when you look at them up close. And so they're just a little bit different formulation, but you can see those things at Menards or Home Depot. Now there's other ingredients that we use in concrete. I use reinforcing bars, which I'll show you on another slide here. But we also can use things like fibers, which is what's in this piece here. These are different types of powders that have some of the cement properties. For instance, volcanic ash has some, and that's what the Greeks and Romans used, or the Romans used. That volcanic ash also has some of those chemical properties of cement. And so we may have different replacements or additions that we use for different properties. And then we have certain chemicals that we use for certain properties as well, maybe to make it flow better or to get that air distribution in there, for it to set faster so that I can drive on it faster, all kinds of different chemical admixtures that can be used. Other ingredients include, I can also put colored powders in it or color the cement. And so I can actually have the colors all the way through the concrete itself, or I can paint it. If you put the color in as a mixture, you basically have a maintenance-free color. So it's not like paint where it's going to wear off. All right, history. The Romans were the first to use concrete, and it was made out of the volcanic ash that had that property, that chemical property, similar to what today's cement have. So around 126 AD, this is the Pantheon in Rome. It's really amazing because it's a 142-foot wide unreinforced concrete dome. Unreinforced means it's just plain concrete with no steel in there. And it's quite an amazing structure. They would use horsehair as kind of a reinforcement for this stuff. They say unreinforced, but they'd use horsehair to kind of hold some of the particles together and make it less brittle. And they also used some kind of old-timey admixtures to delay how long it takes to harden the concrete to get it in place. And some of those admixtures, I hate to say, were like blood. All right, so rebar. So you may have heard of rebar. It's the reinforcement. Concrete is really, really good when you compress it or squish it. When you try to pull it, it's really brittle. So if I think of like a piece of chalk and I push it and try to compress it, it's pretty hard. But if it's very easy to snap into, right? So that's similar to what concrete is, a very brittle material. So I need to put steel in there when I'm going to see the concrete being pulled or in tension. So if I have a beam, I'm going to make a dog keeps, all right, I'm going to make a little beam here, right? It's resting on some pedestals. If I put a load on that beam and it starts to bend downwards, I will get cracking on the bottom. So what I do to deal with that is I put steel across the place where it would crack. And that's where I put the reinforcing. So anywhere there's going to be tension or pulling, so compression, if I look at a little cylinder, compression would be pushing it together, and it's very strong that way. But it's only a portion of that strength. If I start to turn that around and pull on that same cylinder, if I was able to do that, it'll break. Okay, so if you see a wall or anything else like that, let's say you go into your basement wall and you see this kind of cracking, that means that there is somehow tension along that direction, pulling. It's what we call shear. But this is common to see in, like in a home inspection, you may see this, and depending on how serious it is, it could be a problem. So up here, guys, tie-in or steelworkers tying what we call the cage. So these are green because they have epoxy to protect the steel on them. And over here in the bottom left, we've got steel that's going to go into big tall columns. All right. Better keep it moving here, huh? Some cool concrete lingo, just in case you ever, want to throw this around. I'm sure it's a hot topic at all parties. That's supposed to be funny. This guy up here is finishing the concrete. This device that you see down here on the left is called a bidwell. So you'll see these, they're good. What they do is they drop the concrete down from the mixer, and then they come across and they do the finish work for you. So these guys are just trying to make sure that they, and I shouldn't just say guys, although these pictures seem to have a lot of guys. There are absolutely women on the team too. You can see that the workers here will be just making sure the concrete gets in place, but the bidwell actually paves the structure as it goes, which is kind of cool. So we cast concrete, we don't pour concrete. Technically, we should be saying we cast the concrete. Screed is when we kind of take a device and take the excess off the top. Float is we move maybe a board or a larger tool like this across to bring the water to the top so that we can finish it smooth. If any of you end up doing a summer construction job, you may get a chance to see some of this in action. We talked about concrete, but there's also grout and mortar. Mortar has no rock, but it's got sand. Grout is just cement and water and admixtures. A couple other ones here. Similar to the bidwell, this guy here is making a median, right? And so this concrete is so thick that it actually just drives in this direction, and the concrete is formed without having any exterior form work on it. And you guys are welcome to ask me questions next week when I'm in class. So I'm going to go fairly quickly now with this. This is called shotcrete, where you spray it in there. So we use that for pools. This is concrete that's formed to look like stone. So I can have a really cool stone floor of any color I want using concrete. And concrete takes the shape of whatever you want. So if I make a form that looks like stone, I can have that. Up here, this guy, you can see it's got colored concrete as well as different shapes. And whatever I can form, I'm able to cast in the concrete. Some cool stuff. So over at UMD, we do a concrete canoe, and the team has won quite a bit. It's kind of interesting. I can talk about that more next week too. We also do a concrete bowling ball. So there's some interesting stuff that we do kind of as student competitions with concrete that you wouldn't expect. And finally, I specialize in a certain type of concrete bridge, and it's called a precast segmental bridge. So the Stillwater Bridge, the new one down south towards the cities, is a precast segmental. The I-35 bridge, the one that was replaced of the steel one that came down, is also now a concrete segmental bridge. So these are really cool. We build them out from the pier, and then when the other pier comes into play, we connect them, and they can be built with really, really tall columns without disturbing the earth below. So that's kind of cool. And there's segments. And so, for instance, I went to Hong Kong because I'm working on a case about in December last year. And I basically walked inside the segment along the bridge from Hong Kong to China to take a look at the condition of the bridge. This one is one in Pennsylvania that I helped design. when I was working for a bridge firm while I was a faculty member at Penn State. So this is not actually rock. Looks like cool rock stuff. That's also just a form and coloring. And finally, I'll just end that concrete is cool part here with the slide of Frank Lloyd Wright's Falling Water. This is one I'll talk about a little bit next week. I would say just notice that these overhangs, which are called cantilevers, are kind of sloping downward. Okay, so I worked on the project that helped fix Frank Lloyd Wright's Falling Water. It's been probably 20 years at this point, but we'll talk about that one next week. All right, let's go into the zombies here. Okay, so this is a separate talk, but while we're on the topic of concrete, I thought this one might be a little bit fun. So I give this a lot of times at Halloween to different groups, and I always say you're going to get to learn about zombie-resistant structures from someone who's a licensed structural engineer. So I'm going to be a little tongue-in-cheek with this, but hopefully you'll have a little fun with this. It also, even though I'm joking around about the zombie part, everything I tell you is actually true about concrete structures, and thinking of zombies as a kind of a fun way to look at designing concrete structures. All right, so first, I called it zombie resistant structures. I purposely use this word resistant because is there really anything that's zombie proof, right? We can make it as good as we can. This is true with earthquakes too, by the way. So we call them earthquake resistant. They're not necessarily supposed to be earthquake proof because it just costs too much money and we don't always know what the next earthquake is going to do to the structure. So we make them as resistant as possible. And resistant means I'm trying to keep everybody safe. It doesn't mean the structure is going to look perfect afterwards, but everybody's going to be safe. That's my goal as a structural engineer for what we call extreme events. So earthquakes, major fires, all this type of, and of course, zombie apocalypse. So we're going to do a little overview and learn a little bit about structural engineering, which is part of civil engineering, by looking at zombie-resistant structures. So we're going to talk about how you design them, how we would use a code. So instead of computer code, I'm talking about like a building code. So when I build a structure, I have to follow the rules, and they are part of the law basically for that area, and those are the codes. When I'm not at Marshall, I work for the American Concrete Institute and also teach classes, but I am a specialist in developing these codes for concrete. Talk about the different pieces of that, materials, features, and then how we put all that together for a concrete zombie-resistant structure. We'll talk a little bit here about load, but I'm going to touch on this next week. We use what's called a load and resistance factor design. That means that I have what's the structure going to be loaded with and how am I going to resist it. So the load is the self-weight of the beam, the people in the structure, the zombies attacking the structure. Resistance is I'm using beams and columns, and they're made of concrete. Okay, so different things. Like a column, when it fails, it's really dramatic. When a beam fails, I have some warning. And so I have a factor on each side of this equation to make it safe. It's basically a safety factor. Without going into it, here's some different loads, right? And on the resistance side is the strength. How big is the beam? What is it made out of? How reliable is it? When I look at my loads, what's interesting is that I put a multiplier, so a safety multiplier. I know dead, so dead load, haha, so zombie kind of is a dead load, I guess, engineering humor. A dead load is self-weight. So I know once I make a beam, basically how much it's going to weigh. So I only have to add a 20% safety on that. It still has to be built. There are, it's not perfect. Pouring concrete is not a perfect science. Live loads are things like people, anything that can be moved around, like the furniture in the room. And so that I don't have quite as much control over, so I get a 40% tax on that. I get really high taxes on things like earthquakes, blast loads, but they don't happen as frequently. So I know there's going to be self-weight, and I know there's going to be some sort of live load. Um, but earthquakes, they don't happen all the time, so I do some uh, weighting of how likely that's going to happen. Say the zombies, unless we're in a zombie apocalypse, that zombie multiplier, I might make it high because I've got a lot of unknowns with that. But I also might say if I combine dead load, live load, and zombie loads, I'm probably not going to have all of those at their maximum at the same time. So I'll come up with some combination to put in the zombie multiplier. Now, there's some unknowns with the zombies as well, right? So I don't know about you, but if you've watched any zombie stuff, some of them are super fast, depending on the movie. Some of them just kind of skulk around. And a zombie, I don't know in the zombie apocalypse if I'm going to get a bunch of skulking zombies that walk really slowly and are really dumb, or if I'm going to get these like super zombies that are fast and attack and can climb and all that stuff, right? So I may have to have a little higher multiplier because it's just too many unknowns. So the first thing that we are most worried about is safety, right? So the safety is this piece I'm showing you here where we put these big factors on, right? So we want the structure to stay standing. Now, we would also like to be able to have the structure perform as intended, right? We want to have some comfort in our zombie house. We want it to be functional. These things are actual structures that someone decided not to put any windows in. So not super functional on a daily basis, it'd probably drive you crazy, but or it just would just be too much to not have any daylighting. But in a zombie apocalypse, that may be the easiest solution, right? So to think about the trade-off of comfort and functionality. We also, with zombies, are going to have to really think about resilience. So this is a picture of a concrete house after Hurricane Katrina, and there used to be houses everywhere in this picture, but the hurricane took the houses down, and only this concrete one was surviving. And I'll talk about some of the functional pieces of concrete that make this a good material when we have extreme events. So resilience, just like a person can be resilient, a structure can be resilient. The idea is to be able to resist an extreme event, keep everybody safe, and have minimal damage and minimal disruption. So still functioning after the event. And the faster I can get that back functioning the way I need it to be after the event, the more resilient it is. So I can choose a lot of materials. I've just told you that I'm pretty partial to concrete, so I'm going to be going with concrete on this. The things that make me lean towards concrete are we've got strength. I can shape it any way I want. It's really durable against things like fire and water. It doesn't mold, it doesn't rot, it's fire resistant. It's pretty available. I it's weight's something we consider. In this case, heavy weight is not a deterrent. If I was making an airplane, concrete's not a good choice, but for a zombie resistant structure, it probably is. So kind of funny, this picture, I've had this in this talk for a long time, and then I took my son, who went to Marshall, to Rensselaer RPI in Troy, New York. And when we were out there, we had a day and we went and looked at we were looking for something to do in Albany, which is right next door. Turns out this structure is a structure in Albany. So I have pictures of him with my zombie resistant structure, which he thought was pretty funny because he's actually heard this talk before too. What are our design options? Well, we can make the structure zombie resistant by the zombies not being able to get in a couple different ways. This is kind of a silly one, but if I had, someone posted this on the internet, if I had treadmills all around, the zombies could actually power my house and not get in, right? Assuming that they're not the kind of zombies that actually can just climb up over the treadmills. Me personally, I don't want to take that chance. I'm going to make it proof for all the different types of zombies. But things to think about if you're designing, right? Do you want to have underground? Do you want it to have some kind of drawbridge so that they can't get, you can pull the drawbridge up and you have a moat? Maybe you've got some shutters and movable walls so that when you're living in it, it's okay, but then you close it up if the zombies come, right? Renewable energy. Basically, the way I like to think about, or the way I was taught in school to think about structures is we want belt and suspenders. I only need a belt or suspenders to hold up my pants, but if I have both and one fails, I've got the other one. So here's some of those fun options. Movable walls, we've got a drawbridge, shutters. These are some actual houses that are kind of fun. You can see this is actually the same house, right? But it's functional on a day-to-day basis, but if the zombies come, I can lock it down and hope that they are not able to get in. This looks pretty locked down and tight. I can make it very remote. This is an island that was gifted to Bjork, if you know who Bjork the singer is in Iceland. So this is an island off of Iceland with Bjork's house. But an island, if the zombies can't swim, which most of the movies tell us they can't, but who knows, this might be a good option. Of course, you're stuck there as well, and how you have supplies and sustain life there is another question. If you're looking at a whole community, having a zombie-proof exterior, but being able to still have open living space inside with a courtyard type setup is a good option. I'm kind of partial to raised structures but I have to make sure it's not something the zombies can climb up the pole and get in or something like that. So some version of a raised structure might be interesting. Here's another one. Looks a little bit better on the zombie proof piece because they hopefully can't just climb up and around. It's got the drawbridge concept. Then, of course, there's underground as an option. Okay, so this is a real structure, by the way. Can't remember where I found that, but they've got, and then there's, of course, silos, old silos that can be repurposed. Now, the biggest problem with underground is you really have to think about your air systems and how well we can handle having no natural light, right? So there's some life underground is a little tough, but if you have this, back when I was a kid in school, this would be for a nuclear attack during the Cold War. I was after the Cold War, but it was still on everybody's mind. But those same structures could be very good for zombie proofing. So you make sure you limit access here and are real careful with that. But then there's the reality of trying to live underground. Here they've had screens that they're using as a fake window to the outside. This is an actual website for Hardened Structures LLC. You'd be surprised what you find on the internet as far as this type of stuff. One of the most sustainable things you can do and cost-effective things you can do is actually convert an existing structure. So these pictures I've been showing you are real structures. Water towers, missile silos, like we just talked about, bunkers, other structures designed for resiliency. So this is kind of not the prettiest thing in the world, but this type of structure might be, if this is your living area essentially and you can lock down, might be a really effective zombie-proof structure. Here's one. I think when you have these kind of overhangs, there's a good chance that this would be hard for a zombie crew to scale. This is another water tower. Here's a water tower, very effective. Here's a kind of dome concept. All right, so I personally think some of these water towers and domes, I like that structure in Albany, New York, to be honest, because it seems to be one that would be pretty tough. So that one where I started out back here, an existing structure. This is a music hall, actually. So they did this for acoustical reasons, but this one would be pretty hard to scale. And you can really lock it down. But I want you to use your imagination because, sorry for the flipping through the slides, it's time to start looking before it's too late and the zombies come. You need to start planning your resilient community. and figuring out your emergency structure. So, as our kind of assignment for this, I'd like you to develop a zombie resistant structure made of concrete for a client in Duluth, Minnesota. So just use your imagination, right? Describe the structure and give me a little hand sketch, or you can draw it up on the computer if you want, whatever you'd like. But here are the criteria. So when an engineer gets a request for a proposal, we basically want to know what the criteria is, just like you would want to have a grading matrix or rubric. And so I'm the client, and what I'd be evaluating this on, is it practical? Is it resilient to the zombies? Right? Is it economical? And are you using concrete kind of appropriately? Or like you getting the concrete can't be teeny, skinny little spindles because it needs to have the reinforcement, and it typically is pretty robust. But I can use this to help with my resiliency, for instance, for staying cool or hot or what have you. All right. Anyway, don't worry too much. This is kind of more of a creativity thing, but think about the things we talked about here and develop a zombie resistant structure. And I will talk to you all next week. Thank you.